Started with this last section. Remember, tomorrow, come with questions, come prepared to get done with everything, make sure you're clear on how everything works. We are going to have a short quiz.
How short is the quiz?
I don't know, maybe 5-10 problems. Okay, not too long. And then you've got a nice long weekend, so if you're done with everything, especially done with your e-portfolio and all that sort of thing, because remember that's due on Monday, then you can walk out of here tomorrow afternoon, no math to worry about, no homework. Hopefully you're in good shape that way. Okay, so this section is on something called rational equations. There is only one side to the worksheet. I do want to warn you on the Math Excel, because this is a pretty straightforward idea. It looks like it's pretty ugly, but it's a pretty straightforward idea. When we get done with this, you're going to have time to work on Math Excel, but there are also some review assignments on Math Excel. So you know how sometimes maybe there's 20, 25 problems, and maybe 16 of them are the topic that we covered today, and then there'll be a few that are review. There are a couple that are review, and there are a few story problems that are review. They put those in there because those don't go away. They're going to come back. They're going to be on tests. They're going to be on the final exam and stuff like that. So make sure you spend some time figuring out how those work. So we're going to start off today by talking about some stuff that we learned in 1.3. In fact, we solved this equation right here. Okay, so this equation was 1/4 y minus 2/3 y equals 5. Pretty simple linear type equation, but it's got fractions in it, so it's not that fun to work with. But we made the point that if you have an equation, and it's got to be an equation, you don't have to work with fractions if you don't want to. Now, that doesn't mean the answer isn't going to turn out to be a fraction, or there might be fractions somewhere along the way, but it means you can get rid of them and make the work a little bit easier. Okay? And the way we did this is we said, look, what could we multiply that would cancel off a 3 and a 4? What's the smallest number we could multiply it by that would cancel off a 3 and a 4? A 12 would. You could multiply by 24, you could multiply by 48, but 12 is the smallest thing. So when I multiply here, the 4 would cancel with the 12, it would be a 3, we'd have a 3y. When I multiply here, the 3 would cancel with the 12, there'd be a 4 left, 4 times 2, so this would be 8y. And then do I need to multiply over here because there's no denominator over there? Do I need to multiply 12 by 5? I do. Multiply those together, I get 60. Wouldn't be fair to multiply one side by 12 if I didn't multiply the other side by 12. So we went through and we said, you know what, then I can just solve this one. And that's a lot easier. The answer happens to be 60/11ths, which doesn't reduce. We'd leave that as a mixed number, or excuse me, an improper fraction, rather than change it to a mixed number. Okay. But remember, you can only do this if it's an equation. Yeah. Oh, to minus. Very good. Always count on John to make sure I don't make any arithmetic mistakes. So that would be -5, so our answer would be -12, so it would reduce. We could change it to a regular old integer, regular old whole number. Okay, so a couple things we want to be aware of. Make sure you multiply every terms on both sides by the same thing. So just because that doesn't have a denominator doesn't mean we leave it out. Okay, these are division problems. So each one of these has a little division problem in it, at least somewhere. So you've got to be aware of any domain issues. There may be numbers that won't work when you plug them in. Okay? And you'd also want to be careful with subtraction. Make sure you distribute correctly. Okay? Put things in parentheses and stuff like that. So we've got little division problems. We've got to be careful for that reason. We've got subtraction. We've got to be careful for that reason. Most people tend to make more mistakes with negatives and subtraction. So let's go ahead and solve this one. Now, last thing I'll say before we get started is make sure that your answer actually works when you plug it into the equation, because that's really what a solution is. It's a number that makes the equation true when you plug it in. So, do I have to be worried about any domain issues on this particular one? Why not? There's no variables in the denominator, so I don't have to worry about that. I want to multiply by something that will cancel off a 10 and a 15. What is the smallest number that will do that? 30 will. So I'm going to multiply both sides by 30. Now I'm going to write this out on the first one. I'm going to write 30 times t over 10 plus 30 times t over 15 equals 30 times 1. So see how I'm distributing that through to each one of the terms on both sides? Then I'm going to go through and I'm going to cancel. I'm going to cancel the 10 with the 30, that's going to be a 3. I'm going to cancel the 15 with the 30, that's going to be a 2. Nothing cancels over here, so here's the equation that I'm solving. 3t plus 2t equals 30. So 5t equals 30. So that means t equals 6. I get one answer on this particular problem. If I take that and I plug it in, it would work. I don't run into any domain issues or anything like that. I get 6/10. 6/10 plus 6/15. If I got a common denominator and combine those, they'd add up to be 1. Okay, are there any questions there? Okay, do I have any domain issues on this one? Nope. No variables in the denominator, so I'm not in any danger there. So we want to multiply by something that will cancel off a 4, a 6, and an 8. What is the smallest number that will cancel off a 4, a 6, and an 8? 24 is the smallest one that will do that. Okay, now on this one, I'm not going to write it, I'm just going to talk about it. When I distribute through here, 24 times that first term here, the 4 is going to cancel with the 24. What's going to be left? A 6. So this is going to be 6 times x minus 5. When I multiply here, 24 is going to cancel with the 6. What's left? A 4. Now grab this sign. It's a positive 4 that's left, times x plus 6. And when I multiply here, 24 times 5x over 8. The 8 cancels with the 24. There'd be a 3 left. So it's 3 times 5x, so I'm just going to go ahead and write 15x. Okay, are there any questions there? Okay, from here on, it's just like solving any other equation, so normal rules apply here. So we're going to go ahead and distribute through. John, correct me if I make any mistakes, okay? I combine these terms together, I get 10x. This is going to give me a negative 6 equals 15x, and then I've got a choice. I can either move the 10x to the other side, or I can move the 6 to the other side. So a lot of people like the x's over on the left side for some reason. Does it matter? No, what's the easiest thing to move? What's the quickest way to solve this problem? Move the 10x. So I'm going to subtract 10x. Those are going to go away. That's going to be a negative 6 equals, and this is going to be a 5x. Now the interesting thing about this is, when we go through and we solve this, we didn't have to work with fractions once we got rid of them here. Everything was whole numbers. And then when we get done, we get x equals negative 6/5. So the answer is a fraction, but we didn't have to work with fractions in the meantime. Okay, any questions? Sure? Okay, look at the one right below. So I've got t plus 6 over t equals negative 5. T plus 6 over t equals negative 5. This is a rational equation because it has a rational expression in there. It's got a fraction in there. Okay, we want to multiply by something that will cancel off. Well, let's see, the only denominator I need to cancel off is a t. So what will cancel off a t? A t. So we're going to multiply by t. Before I do that, I want to look at the original problem and see, do I have any issues? Is there anything that would not work? I know for a fact it wouldn't work. Okay, so let's keep track of that. Let's say t cannot equal 0. Now, that's not part of the answer or anything like that. That's just us thinking ahead and realizing, you know what, if I get 0 for an answer, I'm going to throw it out because I know it doesn't work. Does that work? Okay, so we're going to multiply by t. This is t squared, this is 6, this is minus 5t. Now, this is a good review, and this is why you have several problems that are review. In fact, you have problems that are like this in the review section on the assignment. So, this is technically called a quadratic. We'll study more about this, but we've got a polynomial. If we've got something like this, there's no negative 5t property of multiplication. There's a 0 property of multiplication. This is the type where we always set it equal to 0. So I'm going to move the 5t to the other side, and this is what I get. T squared plus 5t plus 6 equals 0. And then I want to do what with this? We want to factor that. Now, luckily, this is an easy trinomial. So I've got a t here and a t here. I'm looking for numbers that multiply to be 6 and combine to be positive 5. Multiply to be positive 6, combine to be positive 5. So that's going to be a positive 2 and a positive 3. Doesn't really matter the order, but stop and listen, because people made these mistakes on the test. When you do this, make sure you actually got it right. Because you can use a 6 and 1 and make a 5. Okay, so make sure you got it right. Do they multiply to be a positive 6? Yes. Do they combine to be a positive 5? They do. So these are the right numbers. Okay. You couldn't use a 5 and a 1 unless one of these were negative. Okay. All right. So what's the answer that comes from here? Negative 2. And the answer from here? Negative 3. Now, are either one of these the things we identified at the beginning that would not work? There's no way they could work. Nope. But if one of them was a 0, we'd cross it out. Okay. Now, just for the heck of it, just watch. I'm going to plug a negative 2 in. This would be negative 2 plus 6 over negative 2 equals negative 5. This would be negative 2. 6 divided by negative 2 is negative 3, and that equals negative 5, right? So we got it right. Same thing would happen if you plugged the negative 3 in. It would also equal negative 5, so it would be true. Okay, slide over and take a look at this one. What doesn't work in that one? Okay, now I'm not going to write that again. I'm just going to keep that in mind. 0 does not work here. So we're going to multiply by, well, let's see, I've got to cancel off a t, a 2t, and a 5. As far as the numbers go, it's going to be a 10. As far as the variables go, it's going to be a t. So when I multiply here, I get a 10. Nice and quick. When I multiply here, I'm left with a 5. And when I multiply over here, I'm left with a 2t. Is that right? So this one's a breeze. 15 equals 2t. That means t equals 15 halves. Just leave it as 15 halves. Don't write it as 7.5. Let's just leave it like that. Do I keep that answer, or is it one of the ones I'd have to throw out? Keep it, because we already said the one you'd have to throw out would be a 0, and that's not it. Okay, are there any questions on this first part? We've gone over 4 problems so far. We don't have that many left. We're good? Okay, so let's take a look here. We're going to do number 29. What would I have to throw out?
3.
I'd have to throw out a 3. Just keep that in mind. What do I multiply by to cancel off the t minus 3? Well, oddly enough, if I multiply by t minus 3 on this side, I get a t minus 1, and on this side I get a 2. And I end up with t equals 3. So that's the one thing that I said I couldn't have for an answer. So we cross this off. We say, what's the solution here? We say there's no solution, and this actually has a name. It's called an extraneous solution. Extraneous solution. Okay? Basically means it's an extra answer that doesn't work. Doesn't mean we did anything wrong. It just means in this particular situation, that doesn't mean anything for us. It doesn't work. Okay? It would make the numerators equal, but the denominators would both be 0. If we divide by 0, that's undefined. Okay, any questions? Okay, let's take a look at number 49. And a lot of times I would put a star by number 49. Why would I do that?
Just because the equal to denominators not in the same order.
Okay, right here, these are in descending order. These are in descending order. This is not in descending order. Okay? If it's not in descending order, we ran into some of these where we were combining fractions, and it was a little harder to get a common denominator if you didn't write them in the same order. So you might as well take the time right now. Let's go ahead and rewrite this. This is going to be 5 over x plus 2 minus 3 over x plus 2, and then I'm going to rewrite this way. This is going to be a 2x minus x plus 4, excuse me, minus x squared plus 4. Yeah.
Is it x minus 2?
Thanks. If you don't know this, I pay John to keep track of these mistakes. He gets like $1 for every mistake he finds. Okay. Should we go ahead and factor it like this?
No.
Okay. Kind of a trick question. It would be better if we pulled the negative out and wrote this as x squared minus 4, because then we have a difference of squares. Should I leave the negative on the bottom? No. Let's write this as negative 2x on the top. Okay, so I slid that up there. I've got that part taken care of. And then how do I write x squared minus 4? Perfect square of x, perfect square of 2. So this is x minus 2 and x plus 2. We good there? Okay. So this problem, unlike the other ones, this one took some work to even get it to a point where we figure, hey, I can get rid of the denominators. So now on this problem, I'm going to multiply everything by something that will cancel off. Well, I need to cancel off an x plus 2, an x minus 2, an x minus 2, and an x plus 2. So if you stop and think about this for just a second, everybody watch, please. This is a common mistake. I want you to avoid it. You think, wait, I need to multiply by an x plus 2 to cancel that one off. I need to multiply by an x minus 2 to cancel that one off. There's another one. I better multiply by 2 of them so I can cancel both of them off, and multiply by 2 of those so I can cancel both of them off. Is that right? It's not horrible, but it would make our work a lot more difficult. That's not what we'd call the least common multiple. It's not the smallest thing we could multiply by that would cancel them off. Because remember, we're distributing this through to each one of them. We kind of get to use both of those, again, every time we multiply it by a new term. So when I multiply here with the first one, what cancels? The x plus 2 does. So I'm left with a 5 and an x minus 2. Everybody watch, please. People make mistakes on this one also. When I multiply here, the x minus 2 cancels, but what they forget is that is a negative 3, and it has to be distributed through to the x plus 2. And on the other side, what cancels? Yeah, both of those factors. So this is nice. We're only left with a minus 2x. So as ugly as this is, look how easy this is to solve once we distribute through. I've got a 5x, minus a 10. I've got a minus 3x, and then minus 6, and then over on the other side I've got a minus 2x. It's basically a linear equation. We get the x on one side, get the number on the other side, and we're going to be in good shape. So this is going to be 2x minus 16 equals negative 2x. I'm going to switch places with the two of these, so that's going to be 4x over here and 16 over here. And I'm going to get x equals, well, if I divide, I get x equals 4. Now, is this an answer that actually works?
Yes.
What would be the only numbers that would not work? Negative 2 for this one, 2 for this one. So because it's not one of those, we get to keep that. If you wanted to check and plug it in, it would actually make that equation true. Okay, are there any questions there? Sure? Can I slide this over? Okay, let's do the last two then. So we've got this ugly equation right here. The hard part about this is, like the previous one, it's not even factored yet. So let's go ahead and factor this. So this is going to be 3 over, does anybody recognize this? Perfect trinomial square. Perfect square of x, perfect square of 3. Multiply those together, you get 3x, and double it, you get the right middle term. So this is x minus 3 quantity squared. We've got the x plus 2 up here, and I'd factor out a 3. I'm left with an x minus a 3. And on the other side, I've got an x on the top, and I take out a 2. I'm left with an x minus 3. Yeah. Dang, John is getting rich today. Got it? See, I'm going to blame that on talking and writing at the same time. And the fact that I favor plus signs. I mean, it's just a fact. I favor them. Oh, that's nice. That's really corny. What did you say? It's just that they're so positive? Very nice. Well done. Okay, what do I multiply by?
6x.
Okay. I've got to multiply by enough x minus 3s that I can cancel off 2 of them. So I'm going to have to multiply by, an x minus 3. See, I get paid that time. I caught myself. I have to multiply by an x minus 3 quantity squared. I also have to cancel off a 3 and a 2. Well, then they're just plain old numbers. What's the smallest number I can multiply by? A 6. So when I multiply here, let's take a good look. What's left? A 6 and a 3, so 18. When I multiply here, 3 would cancel with the 6, there'd be a 2 left. And one of these cancels. So this is where it gets a little bit complicated. I'm going to write down the plus. I'm going to write down that I've got a 2. I'm going to write down that I've got an x minus 3 left, and then I write down the top. X minus 2. Everybody okay with that? Let's do the same thing over here. Let's take care of the number first. I've got a 6 and a 2. That means I've got a 3 left once they cancel. One of these cancels with one of those, so I've got everything gone on the bottom, which is what I wanted. I've got one of these left, so that's an x minus 3, and then we're left with an x right there. Any questions? By the way, I haven't mentioned it, but did you look at it and figure out what would not work for sure? Where are the domain issues? 3. If we get an answer of 3, we're going to have to throw it out. So let's check and see what we get. Now, this is a fairly complicated equation to solve, because I've got these things that need to be multiplied together. I need to distribute the 3 and the x through. So here's what I get. Let's be careful about this. I get 18 plus, now I'm going to do some work up here. This is x squared minus 5x plus 6. Right? Then I distribute the 2 through. So I can save myself a little bit of rewriting if I do that work here. Again, you're going to want to be really careful with distributing. We mentioned that up above. Okay? Unless you have John watching you, then you're okay. You can just, he'll catch you. Good there? 3x times x is 3x squared. And 3x times negative 3 is negative 9x. Is everybody okay with the multiplication there? Okay, that's, I think, and it should be the hardest part of the problem. Once we get to here, we ought to be on a little bit of autopilot because we know how to solve equations like this. We're going to set this equal to 0. Now everybody watch, please. I've got a choice. I can take these 4 things and move them over to the right side, or I can take these 2 things and move them over to the left. Which would be better? Stuff on the right or stuff on the left? Okay, how many vote for right? How many vote for left? Okay, more votes for left. Not a problem. You can do it on the left, but let me show you why the right might be a little bit better. Okay? This squared variable makes things more complicated, and it's a positive 3x squared over here. This is a 2x squared, so these are like terms, and if I move them over on this side, what kind of x squared do I have? I have a positive x squared. What if I moved this one over here by subtracting 3x squared? Then I'd have a negative x squared. That would be a little more difficult. Not impossible. I just factor out the leading sign, take out the negative, and then go from there. Okay? So if you keep that in mind, it's going to make life a little bit easier. So we're going to move this stuff onto the other side. Okay? Is everybody okay if I just cross the 2 of these off and write a minus 30 over here? Is that okay? And then I also need to get rid of the 10, so I'm going to add 10x. So add 10x here. So here's what I've got. I've got 0 on this side, which is what we like. I've got an x squared. I've got an x. And I've got a minus 30. And at this point, hopefully we're on autopilot. X here, multiply to be negative 30, combined to be positive 1. Multiply to be negative 30, combined to be positive 1. We think the answer is positive 6, negative 5. Again, these are easy problems. Don't make silly mistakes. Definitely don't make a silly mistake on the test. Double check right here. It takes just a couple seconds. Multiply these together, you get a negative. Combine them, you get a positive 1. So the answer that comes from here is x equals negative 6. And the answer that comes from here is x equals 5. Do I get to keep both of those answers? I do. What if I were going through and I solved this and I ended up with one of these being 3? Cross it out. That would be extraneous. Okay? All right. Good? You're going to run across some problems where you have to multiply things together like this and then solve it by factoring. So just keep that in mind. All right, let's take a look at this one. It says a rational function is given. Find all values of a for which f of a is the indicated value. Okay. Everybody watch. For some reason, this messes people up. What if I said, what's f of 1? What would you do with the 1? Plug it in. You put it wherever there's an x. F of 1 means wherever we had an x, we put a 1. So we put a 1 here, here, and here. 1 minus 3 would be negative 2 on the top. 1 plus 2 would be 3 on the bottom, so we'd have negative 2/3. Right? Okay? So what is f of a? Yeah, wherever there's an x, what do we put? So this is a minus 3 and a plus 2. That's what f of a is. If you plug in an a, it should be this. Now, right. Okay, so if we plug in an a, we get this expression. If we plug in an a, they're telling us, well, that expression better be equal to this number. So this is a very fancy way of saying, set this equal to this. Just that we have a's in place of the x. So we're going to solve a minus 3 over a plus 2. Set that equal to 1/5. And how would I solve this equation? Sorry, what? Multiply by the common denominator, if you want to think of it that way. Yeah, we could do that. Okay, so we're going to multiply by 5 and a plus 2 in parentheses. You could also solve this using, if you're familiar with these, you could solve these as a cross product. You could multiply these two together and those two together. It's because it's a proportion. So we end up with, well, let's see, the a plus 2 cancels, so that means we're left with a 5 and an a minus 3. Over here, the 5 cancels, so we're left with a 1 and an a plus 2. And then we just solve that. So we have 5a minus 15, a plus 2. I'm going to get a 4a over here, and this is going to be a, correct me if I'm wrong, John, 17. So this is going to be a equals 17/4. Will that work? And if so, how do you know it will work if you plug it in? What's the only thing that wouldn't work? Okay. The only answer we could get that when we plug it in, it would make this undefined and there's no way it could work, would be -2. Okay. That's where we've got a domain issue with this one. Okay. Any questions? Okay, so let's put this in perspective here.